out of the 100 or so climate scientists we've got here in Hobart, you could ask all of them this question and I guarantee you they would all have a very different answer. So this is just one perspective on what some of the largest changes are. What we're actually seeing as our climate changes is a redistribution of life on Earth, and it's estimated to be the largest redistribution of life on Earth for around 21,000 years, or since the last glacial maximum. So in the northern hemisphere, as the climate warms, we have plants and animals moving north, and we have plants and animals in the southern hemisphere moving south. We also have plants and animals going to higher elevations at mountains and deeper in the ocean. And these changes in distribution are because most plants and animals have a very defined temperature range that they prefer, and as the climate changes, they're shifting with the climate. So they're not changing what they prefer, but they're just moving to keep pace with their preferred environmental temperatures. And there are literally hundreds of thousands of species all over the world where we've documented changes in distribution that are linked to longer term changes in climate. And this is of course just one aspect of climate change that affects ecosystems and that's affecting humans. But when we have a look at what some of these changes in distribution are all around the world, they are, and this is just a very small handful of them, there are literally all different kinds of plants and animals that are shifting in different locations around the world, and some of these are having quite large impacts. They're affecting ecosystem structure and function, food security. You can imagine if a community is very dependent upon some kind of resource and that moves out of their local area. Human health, new diseases are turning up. We've had some examples of that in the marine environment here in Tasmania. People's livelihoods, of course, fisheries in the European Union. There are a lot of arguments between countries over whose fishes whose when they're shifting from one country to another. Feedbacks to the climate system, and greening of the Arctic is an example there. So as the Arctic warms up, trees and shrubs can now grow in different areas, changing the region from white, where light's reflected, to dark green, where the heat is actually absorbed, and it changes the local climate. And of course human culture. So we all like having particular species around us, and Indigenous communities in particular often have very close associations or connections with particular plants and species that they find around themselves. So as our life on Earth is responding to the temperature change, there are a whole lot of flow-on effects in different ways from that. And of course, throughout history, a lot of our battles, either locally or regionally or between countries, have all been over resources. Who gets what? And now all those resources are shifting and moving. So that's just one aspect of global climate changes. Another one, and this is one that upsets me a lot personally, is the Great Barrier Reef and the bleaching that we've had on the Great Barrier Reef. So if you're not familiar with what coral bleaching is, when the water is too warm, the algae inside the coral that the coral depends on for food, it's a symbiotic relationship, the zooxanthellae, the algae, will be expelled. If it stays too warm, the algae won't return and the coral literally starves to death. So initially they go white, but after an extended period of time they'll die. And of course, once the coral's dead, they will then crumble, and it completely changes the habitat longer term for all the fish and other invertebrates that preferred that habitat. And what we saw in 2016 and 2017 was back-to-back heat-related bleaching on the Great Barrier Reef. And what that meant was the top 2/3 of the reef in the shallow areas, which is most of the reef, the top 2/3, 50% of the coral ultimately died in those regions. What followed then in 2018, when they looked at the numbers of baby corals or coral recruitment that was coming into different areas on the reef, that coral recruitment or the baby coral production was down to only 11% of the long-term average. So we've had 50% of the top 2/3 of the reef die, and then the potential for replenishment in terms of baby corals has been substantially reduced. And these are very thorough surveys. So in terms of biological surveys, they are exceptionally robust and detailed. Bleaching on the Great Barrier Reef at the moment is around a 6-year interval on average all over the world. And we're expecting annual bleaching by 2044 on the Great Barrier Reef, but it takes at least 10 years for the reef to recover. So you don't need to be a rocket scientist or climate scientist or any kind of scientist to figure out that, that the numbers there are not looking fantastic for our Great Barrier Reef. Another marine impact, of course, is ocean acidification. And I'm going through these very quickly, but I just wanted to do some of the major impacts. Around 50% of the additional carbon that's released in the atmosphere is ultimately absorbed by the ocean. That decreases the pH and makes the seawater more acidic. It's around 34% more acidic than pre-industrial times. So we talk about 0.1, but it's actually like the Richter scale for cyclones, and that actually makes quite a bit of difference. Now, what happens when the pH decreases is that it makes it very difficult for animals with shells to build shells because of the acidity and because of the reduced amount of carbonate in the water. So we have things like clams, oysters, scallops that find it very hard to build their shells. Other things like fleshy algae actually have an increasing growth rate, and then we have reduced growth of things like urchins, sea cucumbers and starfish. So there's some pretty stark impacts of acidification in our oceans, and some really weird things, and I wish I had more time to go into this because it fascinates me. But fish, for example, you grow fish over multiple generations in more acidic water expected, or the acidity expected by the end of 2100, and they actually, instead of running away from predators, they will swim. Instead of swimming away from predators, they will swim towards the predators. So it actually has fundamental changes to the behaviour of animals in our marine system. That was some quick marine stuff. I would feel negligent if I didn't sort of delve into human society just a little bit. So some quick comments there. Heat waves. We will obviously expect more intense and more likely heat waves. There's some estimates there that by 2030 or 2050 we'll have an additional 250,000 deaths per year from things like malaria and heat stress. And that's just a graphic of, one of the recent summers here in Australia, looking at all the heatwave records. Bushfires, of course, and these are some of the questions that we'd had throughout the Curious Climate project. Bushfire season starting earlier, lasting longer, more intense, and the Australian fire rating actually changed. We had to add another category to account for the kinds of fires that we're seeing now, because the existing category finished at extreme, and that really just didn't cover off on the massive changes that they'd seen in the fire regimes. Sea level and human migration. So predicted sea level rise, which I think Chris is talking about next or shortly. The sea level rise predicted by 2100 is likely to displace 50 million people in Bangladesh alone, so in one country alone. So some fairly major changes in terms of our human systems, and very significant changes for our marine systems. As I mentioned, if you'd put a different one of us up here, we would have come up with different aspects of global climate change that might be relevant, but that was a bit of a high-level marine look. Thanks, Leo.
Thanks very much.